18.1b, reference angles and sketching angles measured in radians. Now, we did a little bit of the sketching yesterday, right? We did this sketching, remember? We're going to do some more of that today, right here. And then we're going to talk about this thing called a reference angle. So, at this point, I'm going to kind of relate this to your project. At this point on your project here, you should have all of the degree measures listed on this inner circle of your project, correct? If not, you should do that now. The radian measures, I'm going to talk to you about that in a few minutes on the other page of the notes. But I'm going to start off here with these three angles. Since this is a review from yesterday, I want you to take a couple minutes and I want you to draw these three angles on those axes. Okay, so draw them starting with your initial side where it's supposed to go. And make sure to do the little swirlies in the middle to show me how many revolutions you're going to get those. All right, so can I start this? Negative 400 degrees. So I know that my initial side is right here, correct? That's my initial side. Negative 400 degrees. Am I going to be going clockwise or counterclockwise? Counterclockwise. No? Clockwise. I'm going to start going down, right? Shouldn't draw my arrow yet. How far, or let me step back actually. What quadrant, 1, 2, 3, or 4, is my terminal side going to be in? Fourth quadrant. So my fourth quadrant, it's going to be right about near the middle. Because this right here would be what? Negative 360. And I have to go a little bit past that to get to negative 400. Questions about that? Beautiful. 110. Again, here's my initial side. Right there. What quadrant is my terminal side in? Quadrant 2. And where is the terminal side in quadrant 2? Is it in the middle? Is it a little bit closer to the x-axis? A little bit closer to the y-axis? Really close to the x-axis? Really close to the y-axis? It's pretty close to the y-axis. It's going to be right about there. And again, I have to do this to show that I'm talking about that angle and not the negative angle that is coterminal. So? And 710 degrees. I think we graphed this one yesterday, didn't we? Or drew this one yesterday. What do I know about 710 degrees? Well, I know that 720 degrees is 2 full revolutions and 710 is just before that. Right? So let's see. My terminal side is like right there. That's 360. That would be my 710. Questions about that? That should be pretty easy for you now. Yeah? Okay. Now let's talk about this thing called a reference angle. I have 2 main rules about a reference angle. And I'm going to list them right here. A reference angle is always these 2 things. It is always positive, and it is always acute. Always positive and always acute. Now, reference angle is probably one of the most important things that we talk about with regards to the unit circle. Excuse me. And here's how you find the reference angle. You ready? The reference angle is always found by looking at the angle formed by your terminal side and the x-axis. So if I look here, here's my terminal side, here's the x-axis. There's actually a couple angles formed. There's one angle right here And there's also this angle. Do you see that? The reference angle, since it always has to be acute, is actually that angle right there. The one that is made up of my initial side, of my x-axis and my terminal side. So I have to figure out what's that degree measure. Well, I know that this whole angle was 400 degrees, right, in the negative direction. If going one revolution was 360 and going a little bit further to 400 gave me my angle, what is this reference angle in here? It is 40 degrees. Now, Mrs. Franken, why isn't it negative 40 degrees? That was a negative 400 degrees. Well, my rule about my reference angles is it's always positive, because the reference angle is not necessarily an angle in standard position. So it doesn't worry about the direction you're going to get there. Does that make sense? Good answer. Whoops. So there's my reference angle. What about in number 2 here? Where would my reference angle be? Well, here's my terminal side. I need the acute angle that gets me to the x-axis. Is that down to the left or down to the right? Down to the left, because do you see if I go to the right, that's going to give me an obtuse angle. So this is my reference angle. So let's think about this. This represents at 110 degrees on my circle, right? But the x-axis is 180 degrees. So what's the distance there? What's that angle measure? 70 degrees. It would need 70 more degrees to get to 180, or to get to that x-axis. So there's my reference angle. Does that kind of make sense? Okay, see if you can figure out the reference angle in number 3. Where's my reference angle? It's this teeny tiny guy in here, isn't it? This was 710 degrees. What would it be to get to the full revolution? 720. So what is that reference angle? 10 degrees. Does that make sense? Okay. You're going to practice that on your homework. In fact, I think the whole first page of your homework, the whole front side and part of the back side is draw the angle, tell me the reference angle. There are a couple problems on the back where I give you an angle that's drawn like this, and I'll give you either the reference angle or maybe this angle right here, which is not a reference angle, but it's something to help you, and you have to tell me what the measurement of the angle is. Like I'm giving you the answer, you give me the problem. Now, one thing about this is these were all in degrees. Well, what did we learn about yesterday? Radians. So we are also going to have to draw them if we are given radians. Now, here's the trick. If I give you an angle in radians, your reference angle must be given to me in radians. If I give you an angle in degrees, your reference angle must be given to me in degrees. Makes sense? Kind of like that whole fraction decimal rule. Okay. So I'm going to show you, we're going to do number 4 the long way, and then I'll show you the short way. Okay? Now, number 4, here's the long way. 7 pi over 4. I'm going to take that, I'm going to change it to degrees and solve the problem in degrees because I understand degrees better, right? So how do I change this to degrees? Multiply by 180 over pi. My pi's are going to cancel. I'm left with 7 times 180, which is 1260 on the top, and 4 on the bottom. And what is 1260 divided by 4? 315. So 7 pi over 4 is the same angle as 315 degrees. What quadrant is the terminal side going to be there? Fourth quadrant. Is it going to be in the middle, towards the x, towards the y? So it's going to be right in the middle of the fourth quadrant there. And it's going to look like that, right? Now from that picture, you can't tell if it's radians or degrees, can you? It looks the same regardless. However, let's think about this for a minute. If this is 315 degrees, my reference angle is going to be right in here, correct? Because that's how it gets to the x-axis. Reference angles never go to the y-axis, only to the x-axis. What is this reference angle in degrees? What was that? 45 degrees. Because if I'm at 315, I add 45, I end up at 360, which is my x-axis. Which is great. However, since this was given to me in radians, I can't leave that 45 degrees in degrees. So I have to take 45 degrees and multiply by what? Pi over 180. That gives me 45 pi over 180, which is what? Pi over 4. So my reference angle, I can't list my answer as 45 degrees. I have to call it pi over 4. So that's the long way. Not super long, but it's kind of a pain in the butt to have to take radians, convert it to degrees, then figure out the problem, then convert it back to radians, right? So my goal here now is to try and get you a little more fluent in radians, all right? So here's my unit circle. It is divided up exactly the same way it is on your project, right? And all of the degree measures are filled in, and you should have all of those degree measures on your project currently. So we are going to start, since we just found what 45 degrees was in radians, pi over 4, we're going to start with that. So at 45 degrees, I'm going to say that that is equal to pi over 4 radians. Does that make sense to you? Yes or no? Okay, so now what I'm going to do is I'm going to highlight all of the 45 degree angles in my circle. So this is 45 degrees. 0 I'm going to highlight too because it's a part of that. But let's see, what's 45 plus 45? 90. I'm going to highlight that guy. Plus another 45, 135. Plus another 45, 180. Plus another 45 is 225, 270, 315, and 360. That gets me around the whole one. So what do I have highlighted here? I have all of the multiples of 45 degree angles. Does that make sense? Now, in each quadrant, we've drawn 3 lines, right? There's 3 lines here, and on your project, there's 3 lines in each quadrant. Which line is the multiple of 45 degrees? The first one, the second one, or the third one? It's the middle one, isn't it? In each quadrant, it's the middle one that is a multiple of 45 degrees. So watch carefully here. This is going to help you memorize this. Pi over 4, I'm going to think about that as a fraction without the pi. If I took the pi off of that, that's 1/4, correct? I'm going to count by fourths around my circle. So if this is 1/4, this line is 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Let me do that again, but this time I'm going to reduce what I can. So I have 1/4. This is 2/4. What does 2/4 reduce to? 1/2, which is pi over 2. 3/4, does that reduce? No, so I'm going to call it 3 pi over 4. What about 4/4? What does that reduce to? Pi. 5/4, does that reduce? So 5 pi over 4. 6/4, does that reduce? To what? 7/4. 8/4 would be 2 pi. And we know that 360 degrees is 2 pi, right? So that makes sense. So what did I just do? I just filled in a bunch of radian measures and I didn't have to do that conversion thing at all. Right? By the way, this is also 0 radians or 2 pi radians. Okay, so let's look at the other angles that I haven't talked about, the ones that are not highlighted. If I count by 60 degrees, will I hit every single one of those lines that's not highlighted? 60, 120, 180. No, I skipped some, don't I? What if I count by 30s? Will I hit them all? Yes. So rather than counting by 60s and then have to count by 30s to fill in the blanks, let's just count by 30s because it covers them all. So now I'm going to highlight all of my angles that are multiples of 30 degrees. 0 fits in that category. 30, 60, 90, right? 120, 150, 180. And yes, some lines are being covered over, like we've already done them, but they're also falling into this, and we'll see what to do with them. So I'm at 180, 210, 240, 270, 300, 330, and then of course 360. So those are all my multiples of 30. Kind of following me? Okay. So what I want to do is I want to find out what 30 degrees in radians is, and then I'm going to use that to count around the circle. So 30 degrees in radians, I would take 30 and I would multiply by pi over 180. What does that give me? 30 pi over 180. What does that reduce to? Pi over 6. So 30 degrees is pi over 6. So what am I going to count those orange lines by? Sixths. Do you get that? So 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. Okay? That's what I'm going to count these by. I'm going to reduce wherever I can. So here's my 1/6. This would be 2/6. What does that reduce to? 1/3. So 60 degrees, I'm calling pi over 3. 3/6. What does that reduce to? 1/2. So it matches up with what I had from before. 1/6, 2/6, 3/6, 4/6. Does that reduce? What does it reduce to? 2 pi over 3. 5/6 doesn't reduce, so I'm going to call it 5 pi over 6. 6/6 reduces to 1 pi. It all fits in. 7/6 doesn't reduce, so I'm calling it 7 pi over 6. 8/6 is 4 pi over 3. 9/6 does reduce to 3 pi over 2. 10/6, 10 pi over 6, oops, I forgot to reduce that, would be 5 pi over 3. Yeah? 11/6. And then 12/6 does reduce to 2 pi, doesn't it? So do you see how I filled that out? Same way, just counting by 6. Now, if I look at all of those angles that I just filled in, I filled them in blue, so hopefully you can tell there's a little bit of a difference in color there. Some of them reduced to thirds, didn't they? If I had gone by 60 degree measures, 60 degrees is 1/3, 120 degrees is 2/3, guess what 180 is? 3/3. 240 is 4/3, 300 is 5/3. 360 is 6/3. So the 60-degree increments go by thirds. The 30-degree increments go by sixths. Now, why is that pattern helpful? Well, it sure helps a heck of a lot when you're filling in the unit circle. If you can remember that process for filling it in, you don't have to be as particular about memorizing those individual radians. What's easiest is if you have at least these three memorized so that you don't even have to do this. Does that make sense? Now, why is this helpful? Well, first off, before I forget, you should be able to fill those in on your project now. Have your degrees in the first circle, your radians in the second circle. Okay, we'll fill in the outer part sometime later this week. Okay. When I come down here and I see 7 pi over 3, do I see a 7 pi over 3 on my circle? I'm looking for the thirds. So 1, 2, 3, 4, 5, 6 pi over 3. Where would 7 pi over 3 be? 1 more pi over 3 up here, right? Yeah? So 7 pi over 3 is coterminal with 60 degrees. So I now know that this goes like that. It's more than 1 revolution, and that's what 7 pi over 3 looks like. I didn't have to do any converting. That would be my reference angle right here. And so let's go back up to the unit circle. If that's where my terminal side is, and this is my x-axis, what's the radian measure of that angle? Or what's the degree measure of that angle? 60 degrees. What is that in radians? 60 degrees is equivalent to pi over 3. So that reference angle is pi over 3. That's the shorter way of doing it because I didn't have to convert to degrees and then convert back. Yes, question?
Couldn't the reference angle also have been pi over 6 since the other side is 30 degrees?
Couldn't the reference angle have also been pi over 6 because the other side, you're talking about this side?
Yeah.
Right here, was 30 degrees? Good question. The answer is no, because the reference angle always has to go to the x-axis, not the y-axis. So it will never be on the y-axis. It's always on the x-axis. Okay? All right. So let's see. Number 7. This one's negative, but it's 10/3. So I need to count by thirds in the negative direction. You ready? Are you ready? I'm just following the denominators. See my denominators, 6, 4, 3? Just following the denominators. This one never ends up being a third. This one does, though. So my x-axis ones are included. So I have 1/3, 2/3, 3/3. You following? 4/3, 5/3, 6/3. Right? 7/3, 8/3, 9/3, 10/3. So negative 10/3 is coterminal with 2 pi over 3. So that's where I'm going to draw it. And I had to go around the circle twice, didn't I? In the negative direction. That was not fully twice. I had to go around it more than once, though. I was approaching my second time around it. So there's my negative 10/3. Again, make sure that arrow's going in the negative direction or clockwise. Now, I need to figure out my reference angle. My reference angle's right there, because again, it has to go to my x-axis. So coming up to 2 pi over 3, that's where my 10/3 pi is, right? My negative 10/3. So this is my reference angle. How many degrees is that? 60 degrees. So the reference angle is 60 degrees. What is that in radians? 60 degrees is pi over 3. So this would be pi over 3. Okay. Now, this one right here, not my favorite, because what do you notice about the denominator? It's not one of my unit circle denominators, is it? It's not 3, 4, 6, or 2. It's different, isn't it? So I can either play around with fractions and figure that out, or I could take this one and go the long way on it, which I think is actually going to be easier in this case. When the denominator is not a 3, a 4, a 6, or a 2, that longer method is probably easier. So if I were to change this to degrees, I would multiply by 180 over pi, correct? Because I want those pi's to cancel out. Negative 5 times 180, oops, 5 times 180 is 900, negative 900 specifically, over 18. And that's negative 50 degrees. So, negative 50 degrees is not negative 45, but it is just a little bit past that. That right there is my angle. What's the reference angle? Isn't it just the same part that actually is the angle? Because it's already acute. What is that? Well, I have to take the positive version of it because my reference angle is always positive. So it's 50 degrees, which is not acceptable as an answer because it's degrees and it was given to me in radians. So what is 50 degrees in radians? 5 pi over 18 is my reference angle. Kind of sort of get it? Okay. Can I see one of the homework sheets, please? I want to make sure you understand the homework really quick. This whole first side, there's 8 problems on the front and 4 problems on the back. For all of these, you're going to be drawing the angle and stating the reference angle. So if I give it to you in degrees, draw the angle, give me the reference angle in degrees. If I've given it to you in radians, draw the angle, and then give me the reference angle in radians. After that, you have a couple problems where you have to practice converting to radians or converting to degrees. And then these ones, I'm giving you the angle, and then I'm giving you another piece of information. In each of these cases, these are not reference angles. Why are they not reference angles? They're not going to the x-axis, they're going to the y-axis, aren't they? But you don't need to find the reference angle, you just need to use that piece of information that I've given you to determine what the measure of the angle is. Now, if I've given it to you in radians, guess what your answer needs to be in? Radians. And if I've given it to you in degrees, then you have to tell me what the angle is in degrees. Make sense? All right, happy studying.